So welcome to KV Chem classes. Today we will discuss about an important topic in organic chemistry, that is electrophiles and nucleophiles. So before going to know that, so we need to know what brings the molecule together in organic chemistry. Okay. So in general, any reaction, for example, I take NaCl with silver nitrate. So it gives silver chloride as a byproduct which is deposits in the solution. So what brings Ag and Cl together? So we know that in the solution form, the NaCl is dissociated as Na plus and Cl minus, and AgNO3 dissociates as Ag plus NO3 minus. So there is electrostatic attraction, force of attraction between this silver and this chlorine is enough to form the bond and deposits in the solution as a byproduct. But in the case of organic chemistry, the direct plus and minus, nothing but cation anion reactions not possible. So what happens in organic chemistry? So charged reagents are came into play while forming the new covalent bond in organic compounds. So for example, in an organic compound, if a organic compound is formed by the reagent which attacks the substrate and forms the product. So this reagent plays a key role in the formation of the final product, that is organic product. So this reagent nature plays a main role in product formation. So what is the nature of the reagents? So based on the charges, these reagents are classified into two types. So first is nucleophile and another one is electrophile. So nucleophilic reagent and electrophilic reagents. So major organic reactions, except pericyclic reactions, major organic reactions are explained by using this nucleophile and electrophile in the reaction mechanism. So without these species, we can't give an good explanation in the reaction mechanism. So next we will discuss it individually. The first is nucleophile. So nucleophile. So by the name itself, nucleo means nucleus and phile means loving. So nucleus, what is the charge of the nucleus? The charge of the nucleus is positive. So positive charge loving species. So these nucleophiles attracts the positive charge. So if anything attracts the positive charge, what is the charge of that species? It should be a negative. So this is the reactant which gives electron pair to the electron poor substrate. Here electron poor substrate means electrophile. electrophile So it is usually negatively charged species. So sometimes can be nucleophile may be neutral also. So for example, ammonia. So in ammonia, this is a neutral molecule which doesn't have any charge, but it is electron rich. Electron rich So it can donate electrons. So that is this NH3, if you put in water, so these electrons fix the proton and form a NH4 plus ion. So this is a nucleophile. This is a nucleophile. Another example is DMS, dimethyl dimethyl sulfide, dimethyl sulfide. So it can also give the electron pair to the electron poor substrate, nothing but electrophile. And so usually we said it is usually a negatively charged particle, so this is more common. For example, Cl minus, F minus, and Br minus, and CH3O minus, methyl oxide, methyl oxy, and C2H5O minus ethoxy. So these are the more common uh, nucleophiles we have seen, and this is the neutral nucleophiles. And sometimes pi bond, also acts as nucleophile. So pi bond, where it is present, so it is present in alkenes and alkynes. So actually alkenes are more nucleophilic than alkynes. So alkenes are more nucleophilic than alkynes. So these alkenes have a tendency to give the electron pair to the electron poor substrate and form the covalent bond. And final type of nucleophile is sometimes sigma bond. Sigma bond also nucleophile, acts as nucleophile. Nucleophile when more electropositive metal is attached to hydrocarbon. So for example, methyl lithium. So it is the lithium. Lithium, we know that alkali metals are very electropositive. So it remains as positive. So this end becomes the negative. So methyl nucleophile, and another example. Another example. So Grignard reactions. Grignard reactions. So in Grignard reactions, we know that so here the nucleophile is this ethyl part is the nucleophile. This gives the electron to the electron pool substrate. So for example, this is reacts with carbonyl. So this nucleophile attacks this electrophilic position and forms the corresponding product. So this is the story of nucleophile. So if you go for overall glance about the nucleophiles, so nucleophiles are electron rich species. So nucleophiles may be a neutral one like ammonia, and charged one like cyanide, and pi bond also acts as nucleophile sometimes. So here the pi bond present here moves and attacks the bromine, and the last one is rare. So this is a boron species. So boron hydride. So boron has more electropositive, so it remains as positive. This electrons is towards the hydrogen, so this hydrogen leaves as hydronium ion, that is H minus. So H minus is a nucleophile. So this is the small glance about the nucleophiles.